And if we are summarizing what Code RealTime is, first of all, so it's a tool for creating stateful event-driven real-time applications in C++. And you could easily see that that description is actually exactly the same as Model RealTime. So what are the differences if we compare with Model RealTime? In this table, I've added some of the key differences worth noticing. So first, there is a difference in what IDE it runs on. So Model RealTime is an Eclipse-based application running on the Eclipse IDE. Code RealTime, on the other hand, runs in Visual Studio Code or Eclipse TEA. There is also a difference in the language that you use when you're creating your applications. So with Model RealTime, you use UML, and in particular, the UML RealTime and C++, while in Code RealTime, you use a language called Art and C++. And there is also a difference here that UML is a quite big language, and there is some overlap with C++. For example, if you're going to create a class, you can do that either in C++ or you can do it in UML. In Art, there is no such overlap. We have removed such things from the language, and it means that Art is a significantly smaller language than UML RealTime and only contains those concepts that don't exist in C++. There is also difference if we look at how the files that you create are stored. So in Model RealTime, they are stored as XML files. In Code RealTime, it's the Art files that you edit that are stored. That's what you put into your SCM system like Git. Code generation is also different in the sense that in Model RealTime, the code generation happens on demand when you are building a TC, while in Code RealTime it happens automatically and updates as soon as you edit something that affects the generated code. The same goes for the validation. I mean, the checks that we run in Model RealTime, there are some checks when you build with the model compiler. However, they are a bit limited. In Code RealTime, the checks are run also when you edit the Art files or the TC files, and they are more extensive checks in Code RealTime. Diagrams is also a difference. In Model RealTime, diagrams have manual layouts. You move things around and place them where you like to, while in Code RealTime, we are currently only having automatic layout. But also note that many things remain the same. So the same language concepts exist. So capsules, protocols, state machines, ports, events, etc. Those things that you know from Model RealTime, they also exist in the Art language and in Code RealTime. Also, transformation configurations are the same with very few differences. So the TCJS files that is used in Model RealTime for building applications, the same TCJS files can also be used in Code RealTime. The runtime library, the target RTS, is also the same, and that's important because that ensures that the API that you use in C++ code snippets is the same. So there are no differences there. And if you look at the generated code, you will maybe at the first glance think that it's identical. It's actually not identical, but almost identical. So we made some improvements in the generated code in Code RealTime, but to the large extent, it's very similar. So any questions on this overview of Code RealTime, what it is and how it compares with Model RealTime?
Sorry, go ahead.
Is there a plan to allow manual layout? For example, a lot of our models are relatively complex, and the layout really helps understanding.
Yes, yeah, that is something we are working on. So automatic layout has its benefits, in particular when it comes to maintenance of diagrams, that you don't need to spend time maintaining them. But as you say, sometimes the automatic layout is not as clear as a manual layout would be. So we are working on supporting the ability to first move symbols as a first step, and later also resizing them and control how lines are routed in the diagrams. Was there another question also?
Yeah, the manual layout would also something that we would be very interested in. One other thing, you mentioned a few minor improvements in the code generation. Will those also be backported to Model RealTime?
Some may. It's a little bit depending on case by case. And one of the improvement, for example, we did because of the way Code RealTime works with that it's more code-centric. So for example, in Model RealTime, when you have a capsule, the class that is generated has the suffix _actor. That is not a big deal in Model RealTime because you reference that name quite infrequently, typically only when you incarnate an optional part or something like that. While in Code RealTime, since we then use C++ to a larger extent, you use that much more often. For example, if you want to add a member function to your capsule. So we have decided in Code RealTime to use the capsule name without suffix. So that is a difference. But we think that is such a small difference that it's manageable, but something that we probably will not backport to Model RealTime.
Yeah, okay, that makes sense.
Yeah, and there are other things that we have done that we probably could backport, like generating some comments to make the code a bit more clear, and some other things. But I think it's a case-by-case decision what makes sense to backport and what makes not sense.
Okay, clear. Thank you.
Any other questions?
And can you inherit from capsules?
Yes, that's the same thing. That works the same as in Model RealTime.
Okay.
So language-wise, it's very similar.
And is there the ability or a plan to be able to? So we have a large framework that we use to build our instrumentation software that is based in Model RealTime, and would like to say we migrated to Code RealTime, would like to be able to somehow easily port it.
Web application.
Yes,
so there
are two different ambitions we're working on. One was demonstrated on Monday in the Model RealTime demo, where we recently have added support for taking art files you have created in Code RealTime and use them in Model RealTime. So that's an area that you prefer to continue to work for the most part in Model RealTime, but you have some libraries or something that you want to migrate to Code RealTime, and then you could use them in your Model RealTime applications. So basically, it allows you not having to migrate all at once, but more like a gradual approach where you do it library per library. But we're also recently started working on something we call Art Exporter. So that's a utility that you can install on Model RealTime. It's in a still very early phase, but the idea is that that utility should help you convert the whole UML model or parts of it to art files. So that can be something that you can benefit from.
So
okay, thank you.
The key part of the web app
in the hyperlink you see in the upper right corner, that goes to the web page of Code RealTime, and as users of Model RealTime, you already have access to Code RealTime. So there are two versions of Code RealTime. One, a community edition, that is what you get if you install it from VS Code, and then you or Eclipse, and then it will be taken from the public marketplace. So then you get this community edition that has some restrictions, for example, no source code for target RTS and a few others. But if you have the entitlement to Model RealTime, then you should get Code RealTime from the same place where you get Model RealTime, because then you have the full version there. And then you get this in VSIX file, which you then install into VS Code.
Increment that you want to
so
use,
moving on to give the overview of what we will demo today. So in 2.0 we launched the first version of a debugger, which we call Art Debugger. This is very similar to the model debugger in Model RealTime, and in this first version it has the ability to launch the application to debug or to attach to an application that you have already started elsewhere, either locally on your machine or maybe on a remote target machine. And it will then connect over TCP to that application. We support pausing and resuming execution. You can stop and disconnect the debug session, and you can also restart to start from the beginning.
the Node.js web
there is a new view called
and
RtBug
first,
view, which shows the
NPM
application
install is
runtime
done
structure
to
in the form
download
of
the
a capsule instance
packages
tree
and
with the ports. So
dependencies
that
that
is
the web app
very similar to
requires.
what you have in
And
modern real-time.
then
And on
NPM
those
start
ports, you
is
can
entered,
send events,
and
incoming events on
then
ports.
the TCP
And when you do that,
range
you
counter
will be
client
prompted to provide
would
data
listen on
if
port
the event that you
3000
send
by
has any
default.
data. And
Of
also if the
course,
port is
it will
replicated and
then
has multiplicity, you will be
send
prompted
the events
if you want to
to
send it on a
port
particular
1,
port
2,
index
3,
or if you
4,
want to
5,
broadcast
since
to
that's
all
what the
ports.
top
We have also
range
improved the code
counter
generator. That's an
sample
ongoing
is
thing we
listening on.
have worked on for
So
quite a
if
while,
you,
and we still have a few gaps
here's
compared to the model real-time code generator, and trigger operations
web
with
app
parameters
here.
was one such
You
gap that
can
we now have
select a
fixed.
different
So now
event
that is
type,
working, and
I'm
it's also
gonna
handled correctly by
specify
if you use
that the
content-assist in an art
maximum,
file to create such a
number is
transition,
20.
or if you do it in diagrams.
I happen to be running the sample.
Another gap we
on
had was
my
that we didn't
local,
support all scenarios related to port
VM,
multiplicity,
and
so
since
that we have
the
also
port
improved,
that the
and you will see
range
some
counter is
examples of that
listening
in the
by
demo.
default, it's 1, 2, 3, 4, 5. So when
Documentation
I
is also
submit
something we
this,
continuously improve,
then
and
you
in this
could
release
look
we have
at
written new chapters about target RTS, about
TCP
logging,
range
how the
counter
defer queue works, and how
sample,
unhandled messages are handled.
now receives
And
the
then we also
event,
added
and
a chapter
it
about
also
samples, because
acknowledged it
I think we
by
already have
indicating
around 20
that the
samples, so it
max
starts to become quite
value
many,
was
and
set
it
to
was
20.
useful to have this
So
summary and
then
introduction
I
of what
could
each
change
sample
that
shows,
to
so
the
you can pick the
minimum
one that you're most
amount
interested in.
that I want to start counting.
And there are a
at.
few new
So I
samples in this
submit
release.
that, and then in
I
the
mentioned here the
top
distributed
terminal
ping pong,
session
token
where
ring, and
the
TCP range counter.
range
They were all
sample
enhanced
is,
or created in
has
this
started
release.
is,
And these
set
three
to
samples
1.
all make use of a library called
And
TCP server
also
library.
I could
So
change
that
it to
library
the
is
delta
direct port
event
of
to
the library with the same
say
name from model real-time. So it
Uh,
basically allows
it's
you to do
acknowledged
two
that
things. One is
that
to
event
expose a
was
TCP-based
received.
API where you can
And
send
finally,
JSON
I
requests
could,
and have those
set
requests
it
translate
to
into
resume,
injection of events on ports
and it
on a
can
capsule part.
resume counting.
So that's
And
useful
that's
and
pretty
used in the
much,
TCP range counter
the
example.
demo. Are there
The other
any
capability
questions?
is that you can use it as a simple means to build a distributed application where the output from one application is routed to another application. And that's used in the distributed ping pong, where two applications are connected and sending ping and pong back and forth. And the slightly more elaborated example, token ring, that I will show in the demo, where you can connect many applications in a ring and send messages between them. We have also created a web sample for showing how you can use a web page or web application to communicate with an application. And this uses the RT-test probe library that we have used also for model real-time for some time to make this easier in a JavaScript-based context. We also continuously implement new validation rules, and in this release we have added a check related to TCs, so that now if you have a TC that depends on itself through a prerequisite, directly or indirectly, you will get a warning. That's useful to avoid strange build problems if you happen to have this. So also like to give you a brief intro of what are we currently working on, and not all of this may go into the next release, which is 2.01, planned for early November. But these are all areas that we are working on, and some of that will be available in 2.01. So we'll continue to work on the code generator to fill gaps, and one gap is the support for trigger guards in capsule and class state machines. They are currently ignored, but we have almost completed that implementation. We also want to support internal transitions in class state machines that are not supported right now. And we have improved and a bit redesigned the way how we translate choices to make them better. So that will also most likely go into the next release. RtBugger is right now only in its first phase. So now we're working on showing the active state of a capsule instance, supporting breakpoints. At least state and transition breakpoints are quite useful. and also tracing, of course, so that you can trace what communication is taking place in your application. We mentioned already previously here the manual diagram layout. We have a prototype working on this, but we need to test it more to make sure that it's this layout information that we save is always handled correctly and never lost. And then the art exporter, that is not really part of Code RealTime, but it's strongly related, of course, to Code RealTime because it's a utility that we will release separately. Most likely it will be placed on the utilities page on the Model RealTime Info Center. And then you can install that on top of Model RealTime to get an export wizard that can allow you to export parts of your Model RealTime model to art files to be used in Code RealTime. And we have started with the data types as the first step. So if you have data types like classes, enums, type aliases and other things in your Model RealTime application, it's useful to be able to export them so that you can use them from your Code RealTime applications.